If you've made it this far into the waves unit, you're looking at the human eye and you have questions about how it works. So no, I'm not a doctor of any kind, and I'm pretty weak in biology, but I do know the basics of the physical science of how the eye works. So I've broken it down into some steps. Transmission of light, refraction of light, absorption of light, and then a signal to the brain. So I just want to run through these step by step, and this is what I expect for the part of the Vision Basics Mastery Quiz. So here's the eye, and so what we're going to say is we're going to say that some light is coming in from out here, so from right to left, and as this light comes in, this light came from somewhere and it's going through something. So off in the distance here there's some kind of whatever you're looking at, and that light is going through the air. Well, I guess it could be water, couldn't it? So the light is going through some medium. And what's medium mean? That's what the waves or what the light is going through. So I'll add that really quick here. Okay, so the medium is what the waves are going through. So if your eye is, if you're down swimming, you're underwater, or if you're just, in a classroom, you're most likely in air. So the light is going through some medium. And as light goes through something, we call that transmission. So transmission is when waves go through something. So the waves are going through the air, most likely, and they reach the eye. And when they reach the eye, something happens. These waves come in, and unless they're going at perfectly 90 degrees, unless they're coming in, at a perfect 90-degree angle, what happens is these light rays get bent. They go through the lens and these other eye parts here, and those light rays get bent, and they cross over like this. And in this neighborhood, let me switch colors, let's say orange. So in this part of the eye, especially the lens here, the light rays change direction, and that is called refraction. So refraction is when waves change direction in a new medium. So as light rays go from, say, the air into these tissues, they bend, they change direction, and that's called refraction. So the purpose of the lens here, and I don't know how much the cornea and these other eye parts contribute to refraction. I assume they do a little bit, but I really don't know. But the purpose of this refraction is to bring these light rays together so that way they focus back here at the back of the eye. So one thing you should notice is that the way that I drew it, these light rays actually cross over a little bit in front of the back of the eye. So what does that mean? That means like if you're looking at something that's right side up, like maybe a flower pot or whatever, then if the light rays cross over right here, that means that the image that appears on the back of the eye would actually be upside down. And a lot smaller, most likely. So anyway, the light refracts, it crosses over, and it hits the back of the eye. And there's a tissue here called the retina. And the retina is what absorbs the light rays. So absorption happens at the retina. Oh, look at how I spelled that. Redian. Very nice. The retina takes in the light. So another word for absorption is takes in. So the retina absorbs the light, and then from there on, it's a kind of a different game entirely. What happens from there on is the nerves at the back of the eye in this retina tissue, these nerves take a signal and they send it to the brain. So after the light is absorbed, a signal goes to the brain. And that signal to the brain, let's just call that, in this class, let's call that nerve impulses. Let's say nerve signals. Yeah, let's say that. So these nerve signals go to the brain, and then your brain says, oh, I see this or I see that. So that is my 5-minute video on the basic operation of your eye.